Today we're going to be discussing how to start pumps and drives in an industrial setup. Like we all know, we have several methods to start pumps and drives in an industrial setup. We have the direct online starters, we have the star delta starters, we have the soft starters, we have the use of the VFDs, which is variable frequency drives. But for our discussion this evening, we're going to be centered on the direct online starters. So before we go into the practical connections, we are going to analyze the circuit diagrams. Like we all know, in the circuit diagram we have two sections. We have the control section, or the control circuit, and we also have the power circuit. So we're going to, like I said, we're going to be discussing the direct online starters. And we say we have two sections, the power section and the control section. Now, like we all know, the pumps and the drives, most of the pumps and the drives are designed in order to accept three-phase supplies, most of them. But we have other pumps that uses the single phase. But for our analysis of the circuit diagram, we're going to take a look at a three-phase supply. Now for the power section, the supply from the three-phase source, first of all, passes through the circuit breaker. The circuit breaker here is a protective device. From the circuit breaker, it is connected to the terminals of the contactor, the input terminals of the contactors. For instance, here's a contactor. Here's the input terminals of the contactor. Then, like we all know, the contacts of the contactors are normally open. And from the input, the current flows to the output, such that when the contactor is energized, the normally open contact closes. But before it is connected to the electric motor or the drive, we have another protective device known as the overload. Here we see is the circuit breaker. Here is a contact of the contactor, which is normally open. Here we have is the overload relay. Then from the overload relay, it is connected to the terminations of the electric motor. Here is the power circuit. Now we want to discuss also the control circuit, which is what we want to really explain with regard to the direct online starters. The control circuit is actually the direct online starter. Now for the control circuit, we're going to take out one of the supplies. We'll look for one of the supplies into a single pole breaker. pole breaker. The supply is connected to a stop push button. From the stop push button is connected to the start push button. The stop push button is normally closed, while the start push button is normally open. From the stop push button, from the start push button, we connect to, like I explained the other time, we have an overload here. So before the supply here gets to the core, because of this protective device, if you're using an overload, this terminal also has to pass through the normally close of the overload. This is the normally close of the overload before it now gets to the coil, that is A1 of the coil of the contactor, while A2 is connected to the neutral, which is represented by this symbol representing the ground as our neutral. Our neutral is connected to A2. Now, there is what I really want us to understand about this control circuit. Here we see the breaker. When the breaker is closed, current flows through the stop push button because it is normally closed. Now to start the electric motor, we have to push the start push button. We'll push the start push button to make this close also, so that current will flow through the normally close of the overload, then energizes the coil of the contactor. When the coil of the contactor is energized, the normally open contact of the contactor closes. And when this breaker is also closed, by the time the normally open contact of the contactor closes, there's a pathway for current to flow through the overload to power the electric motor. This overload too is a protective device. A protective device in such a way that when the current, the rated current of the electric motor is exceeded, this normally closed contact that is attached to the overload opens when the current coming into the electric motor exceeds the rated current of the electric motor. The normally closed contact here opens, and when it opens, it trips here. When it's open, it's shut out, that is, it de-energizes the coil. But one thing we need to understand is that when the push button is pressed, the push button is being released. Before we continue, let me explain the concept of the push button. Here we have the two push buttons. The one with the red color is the stop push button. The one with the green color is the start push button. The stop push button is normally closed, as you can see from the inscription here. Look at the inscription vividly. You see NC written. That's normally closed. As for the stop push button, for the start push button, if you see the inscription, it is normally open, which is NO. Now, what I'm trying to explain here is that when you push this push button, which is the start push button, and the normally open contact becomes closed, and current is allowed to flow to energize the coil. When you release the start push button, the circuit open, which de-energizes the coil. In order to sustain the the flow of current into the coil, we need to make a connection here. We want to tap a supply here to go through the normally open contact of the auxiliary contact. Here's a contactor. This section of the contactor is the auxiliary contact. So we're going to tap from this connection into the normally open of the auxiliary contact. If you check closely, here is the normally open contact of the auxiliary contactor. Here's the inputs and here's the output of the normally open contact of the contactor, where we are going to connect these two. This where we tap here, pass it through the normally open contact, the input of it, and also from the output of it, we link also back to this section of the circuit. Like we say, this is normally open. Now the idea is, when this breaker is closed and current flows through the stop push button that is normally closed, and the start push button is pushed to close this circuit and passes through to the coil, immediately the coil is energized. The normally open contact closes, creating another pathway for current to flow to sustain the state of the coil, which is energized. It keeps the coil energized so that the normally open contact of the contactor closes, creating a pathway to the electric motor when this breaker also is closed. So the provision made here is to sustain the flow of current to the coil even when the start push button is released. Now to stop the motor from operating, we now press the stop push button. Immediately the push button is pressed. When you press the push button, the normally closed contact becomes open, and as soon as it's open, it de-energizes the coil. De-energizing the coil also, this particular contact that was closed goes back to the normally open state. Hence, the contact here also opens. Therefore, the motor stops working. So, this is just the overview of the direct online starter. Like we say, this is the control section or the control circuit, and this is the power circuits. So now we're going to look at a practical example how this is connected. I believe by then we're going to have a better understanding of the whole concept of the direct online